a raise of hands. How many people are familiar with Docker technologies and have used them before? Okay. So it's really a minority of you. That's interesting. Okay. I'm going to, the purpose of this workshop, at least it was targeted not at really teaching Docker. The assumption was that the starting point is you have your tools packaged in Docker containers. And there's a lot involved with that technology. I'm going to give you a quick overview of that, but the intent of this workshop is not to educate you in Docker. Maybe what we'll need to do is, if the bioinformatics community in general doesn't have familiarity with Docker technology, maybe we need to rethink how we do these workshops and include also a big chunk of time focusing on Docker, on the Docker technologies and how to go ahead and package your tools as Docker images.
But it is also well documented, which Whittle's new. So while it's well documented, this is established already. So that's why we made this choice.
Okay. All right. So I'm going to talk a little bit about basic Docker concepts. Docker is essentially a program. I view it as like it's called Docker Engine, which allows you to go ahead and build containers and share them with others. And the way that you share your containers with others is by publishing those Docker images to a Docker repository like Docker Hub. So when you view a container, it's essentially a virtual Linux environment. And what you're doing is loading an image into that virtual Linux environment. And that image defines an entire Linux environment. So it defines a file system. It defines all the tools that are installed in that environment. It defines environment variables. It defines everything. And then all that you need to do is, if I can go ahead and sort of I can develop a tool, I can make it available to a colleague. They will run it in a Docker container, and their environment will look exactly like my environment. And they can run the exact same command lines to run the tools that I run, and it'll just work. And this avoids the kind of common problem is I'm a tool developer, I build a tool, I share it with a colleague, and it works in my environment, but the colleague says, I can't get it to work, and it's because my environment is different from my colleagues. So rather than just sharing tools, you share entire environments. And that was one of the entire sort of industry is moving towards this level of Dockerization, this level of virtualization built on top of Docker technology, because it really makes for much greater portability.
So is Docker used in an Amazon cloud environment too?
Yes, it can be used. And in fact, we are going to be one of the things that I had you do as initial steps in preparation for this workshop was to go ahead and create your own Docker engine or Docker environment on your laptops. I asked you to go ahead and either install Docker Toolbox or Docker on Mac, or Docker for Mac, or Docker for Windows.
Okay, no, I downloaded the thing, but there doesn't seem to be any easy ability to install it.
Oh, really?
Yeah.
Okay.
Okay.
And one other thing, I think it's important to note that probably this Docker containers are probably in our future. The NCI and NIH are talking about becoming part of this doc store effort, where all publicly available tools would be there in Docker containers. So this is part of a larger effort in the larger community.
So I love the idea of using Docker this way. It's awesome. I've got two questions. I'm thinking the kinds of tools that I need to put into these services. Firstly, what happens if something's MATLAB?
You can go ahead and run MATLAB within a Docker environment.
The licensing is not an issue?
I think you can go ahead and run Docker binaries or executables. Can't you run without dealing with a licensing issue?
I'm not sure. I'm asking.
Yeah, actually,
Eddie
has an answer.
It is possible, and I believe Gordon can confirm.
Yeah, you can run it with the MATLAB compiler. Then you're not going to be able to edit the M code after it's compiled, but you can run it without a license.
Got it. Okay, and then also other things like GHCK, stuff like that are licensed. What do we do about that?
I'm gonna let Geraldine answer that.
All right.
For things like GTK, well, we actually have a public GTK Docker at this point.
Right.
The Docker that's used in production now for running whole genomes on the cloud. The licensing terms are the same, so if you have the right to use GTK that you would download, you also have the right to use it on Docker. The question you're asking is, can you share your Docker that has GTK on it?
Yep.
So we're currently figuring out a way to do that keeps the lawyers happy and enables scientists to do their work.
Sorry about bugging. Sorry about bugging you about it.
Yeah, no worries. But the answer is yes, it will be possible. We have to set some reasonable conditions, but it will be possible.
Yeah, and again, so much of this is developing technologies and emerging technologies. And right now, all of these Docker containers are stored on Docker Hub. But there's a good possibility in the future there'll be public doc stores where tools will be made available. That's certainly where NIH and NCI are heading, I think.
Yeah.
So one other comment about this, I mean, Docker is really terrific and it enables you to do a lot of things on the cloud and you can install it on your computer. But because of security issues, we can't run Dockerized things on our standard internal compute nodes here at the BroadE. You need to have a separate virtual machine that's entirely isolated and sandboxed in order to run Docker, as far as I know.
Okay, because it may be that the Google Cloud and also the security features that are built into FireCloud provide that level of sandbox.
It does.
Yes.
That's right. That's why you can get away with doing it here.
Yes. Right. And for those of you who aren't aware of this, FireCloud is certified as a FISMA moderate system. So it means that it sort of passes a certain sort of level of or a threshold of security features in it that are regularly tested and certified by a third-party evaluator.
But that seems problematic though, because I mean, for little things I can do that on my computer as we're going to do, and I'm excited about that. But
Yeah.
for bigger things, I'm not going to be able to do that on my machine. I'm going to have to send it off to something that we have here. And
Right, and you'll send it off and run it on in the FireCloud environment.
even in testing, that would
Even in testing, and that's one of the reasons why we want to be able to give people the ability to SSH into their containers. Right now, we don't have that ability, so it's very difficult right now to debug workflows or individual tasks within a workflow, issues that arise with large sets of data, because all that you really have access to is standard out, standard error, and a log that's created by Jez. You can't SSH into the virtual machine once it fails and poke around to see what's going on.
So the workflow is, if it's small to do on your computer, you can type the Docker on your computer and test it and dev it there.
Yes.
Small test data, but if it's too large for that, then you jump to the FireCloud immediately.
Right.
Yeah.
Yes, right.
Yeah, and I think long-term, the BroadE will figure out about whether they will allow Dockers here locally, or they say, we're gonna have certain VMs that are set up for doing that, but they're trying to move a lot of the on-prem hardware to the cloud, so presumably they'll have similar kinds of VMs that people could do that on, that they're just eating the cost of them being up, or they say just do it ad hoc, and you'll be charged for, however long you use that VM. I don't know what's gonna happen long-term, but at least for us, we are gonna give the ability to spin up those VMs. They do cost money, and they're having to spun up, but that's kind of the shift that everything is going in here from the, BroadE just handles the cost of all of the hardware to, the cost is to the actual researcher and their funding sources.
Yeah, and the whole industry is shifting, we can't even answer all the questions now. I think the NCI is struggling to grapple with this, NIH, certainly internally, so it's.
Okay, so let's.
We have also, done things where we've spun up an instance on Google, and you can get a very big instance there. Again, you have to pay for it. We have to figure out how to make that a bit more accessible to people.
Okay, so I'm going to quickly run through the rest of these slides on Docker concepts and terms, and it's just so that you're familiar with the terms. I really don't have the time to go into it in great detail, and I don't actually have a lot of the expertise to really be able to go into it in great detail. But the Docker environment runs on top of a Linux kernel. It's running on a physical server. The Docker engine is responsible for spinning up these virtualized containers or isolated workspaces that emulate, on which any versions of Linux can run. And also you go ahead and can run your application within those containers. You go ahead and package or define through a Docker file or with the contents of your Docker image. And it specifies the full environment, the version of Linux that you're running, the disks that are mounted to it, the entire environment. Docker images, these are the things that get loaded into a blank container. They are a read-only template that are used for instantiating or populating a container. It's going to be built by you or other Docker users. These are the things that are published to Docker repositories like Docker Hub and Docker Store and Google Cloud Registry. So within a Docker image, there's a set of instructions for instantiating or bringing up the containers. So it's the programs you install, the folders and files to create, volumes to mount, ports to expose, default command to run when you launch a container. It's the entire environment. And it is stored locally in your Docker machine's image store, and it's also stored remotely in Docker images. So, and we'll be doing this. I have a Docker environment set up locally in my laptop. I have a cache of Docker images. I go ahead and pull those Docker images from Docker Hub to populate my cache. And then I can go ahead and run a Docker image locally. And the Docker engine that's running in my local environment will bring up the container, load it up with that image, and run the program. And we'll see this all in action when we do our Hello World application.
So when you just described it, you said it would run on the laptop. Implies that but does that mean it has to be a laptop that's running Linux as the core operating system underneath?
No, you can also go ahead and run it on Windows and on a Mac system.
When I was trying to download, there was a few different things you could do to download, and some seem to imply that you might need to have Windows 10 and Windows 7, which is our standard here.
Yes.
Is that going to work or not?
It should work. I have not tested this on Windows, so I have to admit that. Yeah. Okay. The important thing to realize is that a Docker container, it's an isolated application platform. It can be built from one or more images that are laid on top of one another, and it wraps everything into the container, and this enables portability. A Docker registry like Docker Hub, an organization can run their own registry, or they can use public registries like Docker Hub, and inside the registry, images are stored in repositories. So for example, at Docker Hub, there is a repository for Ubuntu, one for Red Hat, for NGINX, and there are multiple versions of those images. And you can go ahead and pull down those images to run in a container. And you can specify that you just want to take the latest image, or you can specify the particular version of your image. In our environment, when you create a WDL workflow and a task is going to go ahead and run a particular image, we recommend that you explicitly declare what version of the image that you want to run so that you have reproducibility. But if you want, you could go ahead and say, I just want the latest version of Ubuntu, or I just want the latest version of R, or something like that, and it'll just pull down that version. But we recommend being explicit about the version of the images that you download for reproducibility. Okay.
So just, is that an entire distribution that you're specifying, or is it just a kernel?
This is the entire distribution. Yeah. So if you go ahead and load up a container with a particular version of Ubuntu, it'll look just like a version of Ubuntu that's running on your own virtual hardware. Yes, Gordon?
The kernel is not part of it.
Okay. It's
It's
built on
it's
top.
everything, it's everything but the kernel.
But it looks, once everything is packaged up, it looks just like the Ubuntu release that you went ahead and,
Almost just like, because
Almost,
some
yeah.
features that need access, like mounting, is not really supported, right? Mounting, like not everything could be supported.
The mounting is probably a little bit different.
Yeah.
yeah. So I went ahead and installed Docker for Mac on my system. And if I go ahead and run docker-help, here you can see all of the commands associated with Docker. And it's communicating with the Docker engine that's running. This is because I'm running Docker for Mac. On the status bar, there's an icon here that indicates that Docker is running, the Docker engine is running. I can go ahead and say Docker PS. I can get a list of all the containers that are currently running in my system. Right now, there are none. If I do Docker PS-all, I get a list of the containers that either are running or have run in the past. And they're listed right here. If I would say Docker images, these are the images that I have in my local cache. And there's also a Docker run command. Whoops. Docker run, here are the options. Docker run -- help. And these are all the commands. These are all the options for running Docker, for launching a Docker container. I don't want to go further into the details of this right now. It could really take up the entire workshop. Okay. And we will be executing a small number of these commands, and you can really just copy and paste them from the online version of the recipes that we distributed to you. Okay, a couple of comments about how Docker is incorporated into FireCloud. As I've said multiple times, tasks in FireCloud are run within Docker containers. FireCloud uses Docker Hub as a registry to store the Docker images. Each Dockerized task in a method is run in its own virtual machine that's launched by Jez. And the virtual machine exists only for the time during which the job is executing. Okay, now, if we want to go ahead and be able to support SSHing directly into a virtual machine, we might have to change that so that if you get to a certain point and the system fails and if the task fails, the virtual machine stays available so you can then go ahead and SSH into it and debug what's going on. And Cromwell, the workflow execution system, makes requests to Jez to launch the jobs. Now, when we're running Cromwell locally to test our WDL, it isn't going to be communicating with Jez. It's just going to be communicating directly with Docker, the Docker engine locally. This is as I said, we're going to be testing our WDL workflows locally. Through a local installation of Cromwell. It's our workflow execution service. I gave you instructions on how to go ahead and download the precompiled jar file for this, and it requires Java 8 to run. Have you all been able to download it and get it running on your system? Okay. All right. So, and we'll be giving examples. We'll be doing this with our Hello World. The way that you run it is you say java-jar, you give it the path to the jar file, run the WDL file that you run, and also there's a JSON file that identifies the inputs for this WDL workflow. And you will then go ahead and launch the workflow locally. Okay, the command line, is Alex here? Yeah, right now we have a FireCloud, we have really two FireCloud command line interfaces. One is one that's not publicly available yet, and this is what I referenced earlier. It's a Python client library that allows you to do a lot of activities programmatically directly against the orchestration layer's RESTful API. We also have a FireCloud command line interface that does one thing and one thing alone, and that is upload WDLs to the method repository. And we will be using that in order to show you how to go ahead and upload files to the command line, upload WDL files to FireCloud. A little later on in the workshop, I'm going to ask Alex to come up and show you a new feature that will be available in FireCloud within the next couple of weeks that allow you to use the web interface to upload WDL files to the method repository, and so that running this command line interface will no longer be necessary. Okay. Now we're going to talk a bit about the workflow. You know what? I think I skipped the, I kind of got ahead of myself. I wanted to do the Hello World exercise. So let's go ahead and do that now. And it's all laid out in these instructions that are made available to you both online and also you have hard copies for them. Excuse me? Make it larger? Yeah. Okay. All right. So the first thing I want to do is show you that let me bring up my text editor here. I'll make this larger too. So here I'm using this Sublime text editor, and it does highlighting for WDL, so it's kind of convenient. We have a simple tool that I wrote. It's Python. It just does hello world, where it can either go ahead and take no input parameters or an empty input parameter, and it just says hello world, or if you go ahead and provide it an input parameter, it'll say hello to whatever that targeted input is. Very simple.
So I'm not able to launch Docker.
You're not able to launch
Yeah, I'm
Docker.
trying it on a different machine now. Has anyone got it to work on a PC? Yeah, did you have to change your BIOS?
Yeah. You have to enable virtual machines on your BIOS if it's disabled. It's usually disabled.
Where's the, where did you change it?
In my BIOS, there was actually an option saying enable virtual machine.
I'll try it in a second. I'm copying it up to my computer upstairs, if that may work better.
All right, Gordon, Jason, or Eddie should use them.
Gordon, are you familiar with running the Docker environment on a Windows machine?
I've run VirtualBox on but I haven't run full setup.
Yeah. Okay.
But yeah, there's a couple of settings in the BIOS.
That's issues with Docker Windows, so I recommend using the older version. That's just a comment.
Okay, that's what I did run.
Okay, so how many people are not able to access their Docker environment on their local machine? Okay.
Anyone else? Eddie, or can you come?
Okay, I'm going to, in order for us to keep on moving, I'm going to ask that you do some pair programming and maybe work with the individual next to you and kind of look over their shoulder, because we don't have the time to go ahead and sort out these Windows issues at this point. Okay. So the first thing I want to do is to go ahead and, this is my Docker environment, and we want to go ahead and pull the Docker image from the Docker registry that has bundled into it this Hello World Python application. And this is the command that you're going to go ahead and issue. Docker pull and cburger/hello-world:6.0. And here what we're doing is we are explicitly stating what version of the Docker image you want to go ahead and download. Whoops, and there it is. What happened? I think I got, I see.
So would you show that command again?
Yeah, I'm going to. Here we go. Okay. So it's Docker space pull space cburger / hello world colon 6.0. And in my case, it's going to Docker Hub, and it sees that associated with that is a digest, and it sees that I already have a copy of that in my Docker image cache. For each of you, you may not have a copy of it cached, and it may be pulling it down from Docker Hub right now.
You forgot 6.0.
Yeah.
I'll take your up arrow, then append phone 6.0.
And then what we want to do is just run that Docker container. And I'm going to go ahead and run it through Docker run command. Docker run. Okay. And it runs. Okay. A lot of technology to do something very simple. Yeah. But so this is what you would do. You would be developing your tool in a Docker container, testing it in this local, in that container directly. And once you got your tool running, let's take a quick look at, you can also go ahead and provide it with a parameter, and it says hello workshop. So this is just a simple Python tool. The next thing we want to do is we want to go ahead and run this, bundle it into a WDL workflow. And we provided you with a copy of the WDL workflow, and I'm just going to walk through it very briefly. So this is your first introduction to WDL. Oops, I pressed the wrong button, I think. What happened? Did I just... Don't save. That would be bad. Okay.
The file that I downloaded is referenced
Version
version 5.0.
5.0. Yeah, it's, I did make some changes to it, so it might...
I'd say that
Did you explicitly say 6.0?
when I downloaded it, and then the WDL that you distributed had the 6.0. Maybe I grabbed the
yeah.
the zip file.
Yeah. No, this... I'm having...
Try to extract the new version, the 5.0 version.
Yeah, I don't know what's going on with this. I'm going to just forget about the... Okay. So let's look at the, have you all been able to test the hello world in your container? Now let's take a look at the WDL. So the WDL contains two types of specifications. It specifies a workflow and the tasks in the workflow. The task in this particular workflow is our hello world task. And here we can see that associated with this task is this particular Docker image. It's the same one that that you went ahead and pulled from the Docker registry. And we explicitly declare what the inputs are. So the input here is just a name, and I give it a string, and I say name underscore T to indicate that it's a task level input. And the command line to run when you run this particular WDL task is just calling the Python interpreter and then giving it the name of the Python program. And then what it does is it says you want to go ahead and take as an input parameter to this particular string. And the output is explicitly declared as a file, hello world underscore output.txt. Now this task right here is bundled into a workflow. And a workflow definition includes both a definition of the inputs and the calls in that workflow. In this case, we have a single task workflow. So all that we're doing is just calling this hello world task. And we're saying that the input to this task, the input is defined as name underscore T. We're saying that the input to this task is going to be the input at the workflow level. Okay. Now what we want to do is actually test this running Cromwell locally. Now to test it running Cromwell locally, if you're developing WDL, the first step that you're going to want to do is to go ahead and validate the WDL to make sure that there's no syntax errors. Yes?
So looking at your WDL, in command you're using greater than or less than symbols as opposed to brackets?
Yeah, you can use either. And the reason why you would want to use these angle brackets, they're 3 angle brackets, is because you can have that the command section doesn't necessarily have to just have one command line. You'll see you can have an entire set of bash commands within that. And those commands themselves might include curly brackets. So you have the option of, when you're demarking your command block, you can use either. And we've found, and Eddie has found, that using angle brackets is much more convenient.
Unless you're writing you could be using brackets and yeah.
And you can use another delimiter in that case, like EOF, some people use EOF.
So can you indicate which delimiter you use for command?
I think you can.
That's cool.
Some people put code or EOF, whatever.
All right, thank you.
In your example, is Python required to be on your laptop to begin with? Or?
No, Python is bundled into the Docker image. That's the whole point, that the entire environment, entire execution environment is bundled into the image that you load up in your container. Okay. All right, so what we're going to do now is validate the syntax of the WDL file. And we provide a tool for this, and you have installed it on your system. It's called WDL Tool version 4. I went ahead and installed both the jar file for the WDL tool and the jar file for Cromwell in a directory, in my home directory /WDL/bin. I don't know where you installed the WDL file, so your command line will have to vary from what I'm doing right here. But let's go ahead and issue that. So what I'm doing is running the WDL tool jar file. I'm asking it to validate the WDL that I'm providing it. And the fact that it didn't report any problems means there are no problems. It doesn't really sort of tell you, yes, it doesn't give you positive acknowledgement. It just gives you negative indications if you have a failure in your syntax.
Is there some kind of introduction to WDL?
Yes. Yes, there is a, and we provide links to that. Geraldine's group has done a great job in providing a lot, and Kate has done a great job in providing a very easy kind of path to learning Whittle. And actually, some of the material that they produced is incorporated into the slides that we'll be showing here. I just want, before we actually got into the language elements of Whittle, I just wanted to give you a chance to see the entire tool development process end to end. Okay. The next thing we want to do is when you run a Whittle in your local version of Cromwell, you have to be able to specify what the inputs are. And you specify the inputs in a JSON object. And what we have done is the Whittle tool, you can go ahead and create a template file for that JSON object, which you would then edit. Because the Whittle tool goes ahead and parses the Whittle. It determines what the inputs are for that workflow, and then it goes ahead and creates a template for specifying what those inputs are. And that's what we're doing right here. Okay, so this just wrote it out to standard out. And you can kind of see all it is. It takes a single input. The input is for the, at the workflow level, hello world workflow. And the name of that input is name_WF. And it takes as input a string. What I'm going to do is write that to hello world inputs.json. And then I'm going to go ahead and hello world input. And I'm going to go ahead and edit that. And I'm going to say hello workshop. Okay. The next thing we want to do is to go ahead and execute this workflow using string. Okay, we want to execute the workflow using the local version of Cromwell. And the command is we go ahead and run it, and we give it the name of the Cromwell jar file, and we provide it with both the reference to the Whittle file and to the input file that we just edited. I'm going to go ahead and launch that right now. Input does not exist. Hello world. What did I do?
Oh, it's inputs. You have inputs, not input.
Do I? Okay, inputs. Maybe. Thank you, Eddie. Okay. So what this is doing now is the version of Cromwell obtained the request to run the Whittle file with the provided JSON. It parsed the Whittle. It said, oh, there's one task. And it's going ahead and then launching a Docker container and installing on that Docker container the Docker image containing the Hello World Python code, and it's running it. And luckily it succeeded. And if we actually want to see what the outputs are, you have to kind of drill down here, and you see into the directory that has the output for this particular task. And there it is, cat, hello, world text, and there it is. Probably one of the most complicated hello world applications you've seen. So. All right. Okay. How are you all doing this on this? I don't want to get too far ahead of people who are still running through the steps. And I see somebody squinting, so I'm going to.
Just
Yes.
a comment that that Cromwell will file works fine on Windows, but Cromwell is licensed in Bash.
Wait, could you?
So Cromwell doesn't work on Windows. That's just.
No, Cromwell will work in
But it complains that it cannot find in Bash.
Well, so normally you run it inside the Docker.
Okay, so.
Or sorry, not inside the Docker, but you run it inside the VM.
Yeah, no, you want, probably because I'm running within a Linux terminal, or a terminal within my Mac. Yeah, no, you can't find Bash. So maybe Cromwell does need to run within a, yeah, I'm sorry, I don't know, I don't see Alex here. Yeah, okay, so I'll get an answer for that later on. Would you, Geraldine, or would you know whether or not you can run Cromwell on a Windows platform?
I don't know, I suspect it might not.
Okay.
Yeah, that's fine.
All right.
It's not tested.
I'll run it with a Linux environment.
Right.
Good news is Windows is getting Bash. It hasn't been.
I use Windows.
Okay. Yeah.
Yeah, Windows is getting Bash. So.
Yeah. So I apologize that we really haven't done a good job in making sure that a lot of these exercises work in a Windows environment. Okay, we've taken a look at the output. Now what we want to do is, so we have gone through the process of writing our application in a container, testing it within the container, then wrapping it in a WDL file, testing it locally with a version of Cromwell. Now what we're going to do is upload that WDL file to the method repository and run it within FireCloud. And right now, in order to upload WDLs to the method repository in FireCloud, you need to use the FireCloud CLI. And there is a Docker container for doing that. And there are instructions for running that Docker container. We will be adding, within the next couple of weeks, to FireCloud the ability to go ahead and directly upload your WDL files to the method repository through a web interface. Okay, so I am going to CD to the location where the okay, there's my WDL file. And the first thing I'm going to do is to run the container that has the FireCloud command line interface. And once again, I want to emphasize that this step will be optional going forward because there will be a web interface for doing this. Here what I am doing is running this container, BroadE Institute / FireCloud-CLI. By saying -IT, I mean it's an interactive TTY interface, and the -V is a mounting declaration. So what it's saying is that it's going to mount the home directory on this system, or it's going to mount this file .config in my home directory to a .config file in the root directory of the virtual machine that I instantiate, and it's going to also mount the present working directory to the directory working on that same virtual machine. And the command I'm going to be doing is it's going to be an interactive VM, and I'm saying that what I want it to do is to run bash. And there it is. And if I go to working, cd/working, ls, I can actually see there's this is the contents of my present working directory, but it's mounted to, this is within the Docker container, and I've mounted my present working directory within my machine to the /working directory on the container. Okay. The next step that we need to do is, I'm going to just cd back to this. The next thing we need to do is we're going to be making a API call to the method repository within FireCloud. All of the queries to FireCloud need to be authenticated. So what we need to do is to provide this container access to an authentication token that it can use for presenting to the FireCloud API in order to upload the WDL file to it. And so we want to log into the Google Cloud environment. So you should all log in to the, I'm going to say gcloud auth login. And it provides you with a URL that you should go ahead and copy. Oops, thank you, Eddie. Okay. All right. Okay, so it's asking me to go ahead and authenticate. Now I'm going to choose the account, the Google account that I registered to FireCloud with. So in my case, it's my BroadE account. I click on that, I say allow, and then it displays here the authentication token. I'm going to copy that. And I'm going to go ahead and paste it in here. And I'm done.
And what are we doing right now?
So what you're doing right now is we're operating within a container. Within the container, we are going to make an API call to FireCloud to upload a WDL file to the method repository in FireCloud. To make that API call, all queries to the FireCloud API are authenticated. So we have to provide an authentication token. We obtain our authentication tokens from Google. So what we did was to log into Google, or essentially make a request to Google to provide us with an authentication token. And that's what that string was that I went ahead and copy and pasted into this. So now that it's available, now I can go ahead and make these API calls, and they will be authenticated. Okay. Okay, now what we're going to do is to run the CLI command to upload our WDL to the method repository. All right. right, so what we're doing here is we are, this is we're calling the command line interface. We're providing it a parameter with the URL to the API that we're directing it to. We're saying that we are pushing a method, a workflow up to the method repository. And we're saying that that workflow is going to be written under the namespace. My namespace here is BIRGER. You should go ahead and update, you should change this command line to give it a different namespace, preferably the name under which you have registered under FireCloud. It just has to be unique. And if you are creating a new namespace, then you will be the sole owner of that namespace, and only you will be able to go ahead and publish subsequent WDLs under that namespace. Then you need to specify the name of the WDL. In this case, it's Hello World. And then you also need to specify that you're publishing a workflow, and you need to specify a small summary message of what it is.
Just to add a note on the namespaces, namespace is going to be increasingly important as more and more and more tools are added in. So be thoughtful as you create your own namespace. For tools that we're publishing, we're going to be very clear about what exactly our namespace is for our approved workflows that we'll put out to the public. This will help establish an organizing principle in order to be able to find the workflows you want.
Okay, so I'm going to, you should issue this command, but you need to make sure that you write it under your own namespace. And I'll issue it. Whoops. I probably got the wrong place. No file directory. Oh, I hit CD. So I got to go to. Oh, is it? Oh, slash working. That's right. Okay. And there it is. Okay. Now I've done this a number of, yes.
So we have a question about the namespaces.
Yes.
So here we're publishing things under our own name, but what if we want to publish something under a team name and have multiple teams?
Okay, so somebody would go ahead and create that team namespace, and they'd be the owner. And then as the owner, they can then go ahead and give write access to that namespace to other members.
And is that through the FireCloud?
Yes, it's through the, right now, you have to do that using the RESTful API. But we have a story for allowing management of access control lists on namespaces through the web interface. And hopefully that's going to be prioritized and taken care of soon. But right now, in order to manage the access control list on the namespace, you need to go ahead and make calls against the public API. And that's all, it should be all documented in Swagger. I think there may be an issue with the Swagger documentation for this particular feature.
Oh, okay.
Yeah. No, go ahead. No, you first, and then.
It's just, so what happens, let's say somebody creates a namespace that's like BroadE. Can I go to you and say, hey,
That's
administrator,
we are going to have to monitor that. You know, somebody could create a namespace, you know, IBM or something like that. And
Anything with the name BroadE in it is on permissionless.
Within FireCloud, I don't think that's the case.
Check with Alex, I wasn't able to do the main.
Oh, okay.
I think that's the place.
All right.
we may have to stake a claim to someone.
Yeah, because we want to be able to control, we don't want anybody to arbitrarily create a namespace and then give people the impression that that namespace is the official one. Yeah, and that's another area that we're going to be expanding our functionality on.
And it's it's going to be increasingly important as people have to try to sift through large amounts of tools out there, and this is really going to be the underlying organization.
Because we'll definitely want to be able to indicate clearly when it's been
This
blessed.
upload.
Yes.
Exactly, and I know we have a meeting this week, yeah, the topic.
Now you'll notice that when I uploaded this, I got snapshot 7 because I've done this. This is the 7th time I've uploaded this. For each of you, you probably got snapshot ID 1. Okay. All right. So now let's take a look at. You should each be able to go to FireCloud, go to the method repository. You might have to sign in again because maybe it's been an hour since you've gone into FireCloud. You'll need to refresh the page. And then I'm in the method repository. I filter on Burger, on Hello World. And you can see that these are all of the copies of Hello World that I have uploaded to the method repository. And this is the one that I had just uploaded. 11:43 a.m. today.
Okay, so these names, the method names do not have to be unique, while the workspace names do need to be unique universally.
The workspace names need to be unique universally. What needs to be unique in the method repository is the combination of the namespace, the method, and the snapshot ID. But the snapshot ID is actually assigned automatically to the system. It's not the time, it's every time there is a new publication of a method under the same namespace with the same name, it'll go ahead and increment the snapshot ID. Okay. So each of you should be able to enter the method repository and see the Hello World WDL that you published to it. Can you all see that? Hands up to see the number of people who, that way I can get a sense of how many of you have lost already. Okay. Yeah. And again, we're going to make this more streamlined and easier, and we understand that right now it's a rather heavyweight process. Okay, we can go ahead and see it. Now we want to go ahead and run the tool within FireCloud.
You use the same workspace that you were using before, the mini mutation?
No, we're going to create a new workspace.
Create a new one?
Yeah. Okay. What? Why not? Because I want to upload. Got it. Yeah, it's just easier. Yeah. So I'm going to go to Workspace. I'm going to create a new workspace. I'm going to charge it to BroadE FireCloud Workshops. I'm going to say Hello World. Now each of you, because you're all creating workspaces under the same project, the workspaces have to have the same name. So actually, what uniquely identifies a workspace is the combination of the project and the workspace name. So I'm going to say Hello World, chat, and then I'm going to give the date. That's right, August 12th. You all should go ahead and create your workspace. Just choose a name that you're relatively guaranteed it will be unique under this particular project. All right. Now we have the problem that we had before with Google, where we go ahead and create a new workspace. A bucket is associated with the workspace, but there's a problem with the synchronization or the ability of Google to immediately give the users access to the bucket that's associated with the workspace. And because that's the case, I can't go ahead and run the analysis within that workspace. What I'm going to do is step through the processes of uploading the data model within this workspace, bringing the method configuration into the workspace, But then I'm going to take inspiration from Julia Child. We already started a turkey yesterday, and I'm going to pull it out of the oven. We went ahead and I had created this workspace, a copy of the workspace yesterday, and I can show you what the results are. Because I'm not going to be able to actually run this analysis without having access, write access to the bucket that's associated with the workspace, because all results from that analysis are written back to the bucket.
Is this, can you remind me, is this just a temporary thing? It says that eventually it'll get resolved?
Well, yeah, it's supposed to be temporary, but I waited like 4 hours yesterday, and we don't have that much time. This is a problem with the Google Cloud Platform infrastructure. They are aware of it. It's a problem that intermittently occurs. We've just had really bad luck that it happened to occur during the workshop. And
if we want to use the system, like say, like tomorrow or like
hopefully this won't, yeah.
You still go through the same process, and presumably this, you create this bucket, eventually this bucket's going to show up.
Yeah, eventually, but ideally what will happen is you create the workspace and you immediately have access to that bucket. That's the way the system is supposed to work. Okay. All right, but let's go ahead and upload data to this. So we're going to go ahead and click on the Data tab, and then we're going to import some files. And we're going to input 2 load files, 2 TSV files. The first thing we're going to go and do is identify a set of participants. So I click on participant.tsv. This is all available in the zip file that you should have downloaded and installed and expanded on your system. These are the participants. There were just 5 of them. You go ahead and do an upload. And then we want to also go ahead and import a participant set. So what this does is identifies the set name as ACC, and it lists all of the participant IDs in that set. And we upload that. And now we can see these are our 5 participants, and we have a single set called ACC that has those. So now that we've gone ahead and populated our data model, we want to bring the method into the workspace. But as I've said before, you don't actually copy the method into the workspace. You create a method configuration in the workspace. So we're going to go to the Method Configuration tab. We're going to say Import Configuration. It brings up a window into all of the workflows that are available in the method repo. I'm interested in the workflow that I just added that has the hello world. Each of you should do this the same with your hello world workflow. And I'm going to go ahead and import it into the system. Now, when you import a method into a workspace, you're not bringing the method into the workspace. What happens is the system looks at the WDL file, and it parses it, and it figures out what inputs and outputs are explicitly declared in that workflow, and then it creates a template method configuration for you to fill out. And
you select the wrong group entity type for that method?
I think you can change it. So we're going to edit this, and you can go ahead and change it to anyone you want. Okay. All right, so what we want to do is, so we want to be able to specify where it's going to get the name of the of its input. And I think, Eddie, will you just remind me, if I want the name of an entity?
Oh, it's this dot name.
This dot name. Okay. And the outputs are going to be this dot, say, salutation. How's that? And here we say that the reference method for this is our hello world application. If you want, you can go ahead and expand it to look at what the actual WDL is. And then we're just going to go ahead and save this. Okay. So what we're saying now is that we're going to run this method is going to target a participant, and the input parameter for the workflow is going to be this name.
So you said name, 4 characters, N-A-M-E, but here in this column
Is
there's
entity,
name. So
yes.
what's the?
This is just, it's confusing and we should probably fix that. What we're saying is that, because each of these, it was probably, it was just the way that the UI was designed. But in order to reference the name of the entity in your table, the root entity type is participant. These are the unique identifiers for each of those participants. To reference the name of that entity, you say this dot name.
So would that be for any entity, or
Yes.
is it specific to participants?
It will be for any entity. So if I had a workflow that would target a participant set, and I wanted the input to be this name, I would say this dot name here as well.
So name is the unique identifier for an entity within.
Yes.
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 The name or the entity name is being used as the key. So that's probably why it's a little bit different than the others.
Is that the only assumption on entity is name? Other than that, you supply what the attributes are?
Yeah, you can supply whatever attributes that
But
you
the
want.
only assumption is name, right?
The only assumption is name, but for samples, a sample must be associated with one and only one participant. So there's essentially a foreign key in the sample table that references a participant.
The participating entity, which is the name.
Yes. Yeah. Okay. All right. Now I'd like to go ahead and run this method. Right now, I can't. This block is, this button is grayed out, and it's because of this problem. But luckily, I've run this before, many times.
Can you explain what that problem is again?
The problem is that when you create a workspace, a bucket is created associated with that workspace. And the access controls on that bucket have to give you read and write access to that bucket. We rely on Google to go ahead and do that, and it's not functioning correctly. So there seems to be, and it's an issue of synchronization of some resources they have in their back-end system.
So we can, from this point, we can no longer play along.
Yes, right. But this problem will resolve itself in your workspaces within a couple of hours. And if you want to go ahead, you can go ahead and launch the analysis. Okay. But I think I ran it already. Let's see when I last ran this. That was back in June. Okay. So I ran this Hello World application back in June. And what I actually did was to run it against all of the, I want to get through this so that we can all go to lunch. So Eddie, could we just be quiet a little bit so I can quickly get through this, and then we can all go off to lunch. So I went ahead and launched this Hello World application actually on an entire set of the participants. And what that did was it went ahead and launched that Hello World workflow for each participant in that set. And you can drill down and you can see that the workflow succeeded. The workflow consisted of a single call, and that call succeeded. For each task that you run, the system automatically preserves standard out and standard error and also a JES log. So you can go ahead and look at those files too. You can also see what the inputs were. And you can see that the input for this task was the name of the entity, the name of the participant. And the output is the file that contains the hello world text. Now, because in the method configuration we explicitly declared that the output file is going to be written to this attribute, this .greeting, then if we go back to the data tab and take a look at the participants, we see that there's a new attribute that was created in that data model called greeting. And if we open up any of these files, you can see that the result. Okay? So what we've done, stepping back, is we went through the entire process of creating an application in a container, testing it in the application, wrapping it in WDL, testing it in a local version of Cromwell, then going ahead and taking that WDL file, publishing it to the method repository in FireCloud, and then creating a workspace with some test data in it and running that method on that test data. Yes?
Another interesting step would be all those outputs. What if you wanted to bring those back? How would you do that?
What do you mean by bringing them back?
Let's say you wanted them back on your local computer.
Oh, you would download them. You could download those files. Do you mean the output files?
Yeah, you showed like how for every participant you get an output file. I want to just get all those back.
Well, then I think then maybe what you could do is, if you're going to do it, you would write a task that would go ahead and, well, it depends on how you want to get it back. Right now, the way to get each of those files back is either through the GUI, you could go ahead and download them. But I think there's also a way of writing a script against either, I think actually again using GSUtil, using the FireCloud, using the Google Cloud Platform SDK to go ahead and retrieve those files from the bucket. And you could go ahead and do that. So you can either do it using the GUI by clicking on the file and downloading it, and I can show you how to do that right now. So, oh, I see, we opened it. Oh, I see. Because it's a small file, or it's a text file, it just goes ahead and displays it. Typically what will happen is if we went to any of the workspace with TCGA data and took a look at, say, any of the samples, these are files. These are actually input files. These are the files that are associated with the sample entity. We can go ahead and download any of them if we want by clicking, I think if you click maybe.
Oh, right click to download it.
Yeah, does it? Oh, there it is. Okay.
Okay, but you'd have to do that file by file.
Yeah, or you can go ahead and do it programmatically.
But you'd have to, like, TCG has over 1,000 breasts.
Right, but remember, you
You
don't.
have them in pair sets or sample sets, you download one.
It depends on what you want to download. If you want to download some aggregated data, what you would do is you would write a task to aggregate the data. And then, for example, if you have gene expression file, and so you have gene expression data for on a per sample basis, maybe you want to first go ahead and aggregate all that data into a single file so that you have a file that represents a table where you have each column is a different patient and each row is a different gene. And you would aggregate all of that and then just pull that data down. Just remember that when you pull data out of the cloud, if it's, you get egress charges that are charged to the project that's associated with the bucket. And those egress charges can be significant.
Yeah, I think it's like $1 to download a BAM. So, you know, if you want to download all of TCGA, BAM should cost you $22,000, something like that. So just be careful on that. There should be no need to download any TCGA data because you can compute it on it in the cloud. And mostly your results tend to be very small files. The one exception is people that are working on aligners and testing new alignments. So, but generally your result files are very small.
We have a joke that Google made their cloud platform like a roach motel, where you can move your data up into it, but they really discourage you by having very large egress charges from pulling data out of it.